very much. Thank you for having me. I apologize for Sunday. Actually, when I got in the Uber car yesterday, the driver said, "Where are you from?" And I said, "You don't even want to know." And he's like, "No, I really do." I said, "Boston." And he's like, "You got to get out of this car right now." I'm like, "Hey, what happened to 5 stars, man? Come on." But it is great to be here. Actually, Pittsburgh is a special city for us. We have a great team locally here in Pittsburgh, including our Hadoop and data management team on the Vertica side. I got to spend time with them yesterday. It's always fun to spend time with this team in particular because I feel like it's one of our most connected teams when it comes to the ecosystem and everything that's going around when it comes to big data, data analytics, Hadoop, open source, and a whole bunch of other things out in the industry. So I also think I have a really cool job. I get to spend a lot of my time with some really cool customers understanding their data needs and how they use information to really change their business, or in some cases change healthcare and the ways that services get delivered. And one of the things that hopefully you'll see after this presentation is I really believe we are going through a fundamental change, probably humanity going through a fundamental change in the way that we use information. And as you can see on the title slide, this notion of an ambient cloud, I think as you think about how data is all around us, everything we do is creating data. For better or for worse, it's being collected, used, analyzed, and predicted, and hopefully, usually for better. But I really think it's changing so many products and services that we not only deliver, but we actually use in our lives as well. One of the things I love to start with, because I often get this question from my family members, is, just tell me what some of these sizes mean. Because I'm hearing about crazy things like Brontobyte, which up until last year used to be the largest size data that any of us knew about. And recently they've updated that to a Geop-byte. But I also like to put this in perspective because back in the early 80s when I got my first hard drive, I remember it really well because before then I had 2 truly floppy disk drives that were going back and forth with floppy disks. And I remember arguing with my brother when we got this whopping 20 megabyte hard drive that who was going to be able to keep that hard drive for the rest of our lives, because every piece of information that we had, every game, every Bank Street writer, word processing document, everything was on this hard drive. And we had a ton of room on this hard drive. And so we were already fighting about who was going to take that for the rest of our lives. Now at the time, in the 1980s, I had no idea what a gigabyte was. Probably like many of us have no idea, maybe not quite what a Geop-byte was, but maybe like a zettabyte today. And as I later learned, if I did know what a gigabyte was back in the 1980s, it wouldn't have mattered because it would have cost me $1 million for that gigabyte. And so I think a lot of times we sort of think about big data and we hear these crazy terms and sizes of information, and sometimes we tune it out or think, that doesn't apply, that's not my business, or that doesn't impact me. But I actually think that every single one of us in this room, in the not too distant future, is going to become very familiar with some of these sizes. And I get to see a lot of companies that are actually already doing some interesting things with these. But what I also hear a lot is like, why do I care about big data? What's the big deal? Why do we want it? And I hear some funny answers coming from people, to justify more equipment. Of course, we'd love that. To get more people to manage it. It seems like a hassle. How do we deal with all this stuff? And there's a lot of joking about how many copies of the data there are out there, and do we have control of all the data, and are we compliant with all the data? But at the end of the day, I have seen some unbelievable things happen as a result of information. And I'll tell some of these stories throughout this morning's conversation. Some of the most profound things. Sometimes people just stumble upon parts of these data sets and do things. We have one customer in the healthcare space that was actually looking at a data set completely unrelated, but they ended up stumbling upon a whole bunch of predictors for sepsis cases that were going unnoticed. In fact, they found over 500 of these cases. And for those of you who know sepsis, it can be a really, really actually terminal thing if you don't catch it early. And so just by perusing some of the data, they actually discovered something that materially saves lives. One of my other favorite stories is we have a gaming company. And a lot of people don't know this, but most gaming companies, every time you're playing a game, particularly on a mobile device, every single piece of information is captured about how you're playing that game. So as an example, every place you're pressing your fingers on that screen, the speed that you're using your fingers, and actually how hard you're pressing the screen is actually captured by these gaming companies. Not to be Big Brother, but actually to make the experience a lot better for you. And one of our customers, one particular gaming company, after one of their games, there was a little explosion on the screen. And during that explosion, which actually took only 600 milliseconds, right afterwards, there was a quick flash of a bonus round button. And so what people started doing was pressing the screen as fast as they could to anticipate the bonus button to make sure they were actually going to get the bonus. Well, the data science team at this company was looking at this data set and noticed this bizarre anomaly, which was one person was able to hit that screen 13 times in 600 milliseconds. So they thought, that is absolutely impossible. Like, there had to be 13 people around this phone, or something had to be happening. Well, it turns out that's what drew them to the data, but when they actually drilled down on the data, they found something much more interesting about this data, which was they noticed that this person that hit it 13 times, about a week later, only hit it 10 times. And a few weeks after that was only hitting it 8 times. And so I guess they would call it maybe the second derivative, or the rate of decline, was dropping. And then what the data science team actually found out was that that was a perfect prediction of churn, of this gamer losing interest in the game, but it happened a month and a half before the person actually recognized they were losing interest in the game. So when they had these focus groups, they would say to all the people in the set, not necessarily hitting it 13 times, they would say to all these people, what's going on? Do you not like the game? No, I love the game. I still play the game the same amount that I always played it. And actually, if you looked at the duration of play, they were playing in large part for the same amount of time. But this was an indicator that consciously a lot of these gamers weren't even aware of, but it was a perfectly correlated prediction to them actually churning out of the game. So that may not be a save the world type of scenario like some of the other ones up here, but I think it's really interesting to look at what some of the information can do. And there's no doubt that in the economy that we're in today, which we often refer to as the idea economy, that level of detail and that knowledge around information is really, really important. I know many folks in this room are in the healthcare industry and do work with the healthcare industry. I think this is the most exciting area of big data. I think personalized medicine is going to become extremely real in our lifetimes. But it also is a big data problem. I've heard that if you look at any one individual person, the amount of information, not just DNA, but the amount of information that describes a person is so large that it would fill up 20 Titanics with thumb drives. And so then you say, well, what is the sequencing of the DNA and how big is that? And that's sort of the compressed version of it. And for any one person, that is a book roughly equivalent to 246,000 pages. And any slight deviation means the difference between diseases like cystic fibrosis or not. But as we get closer, maybe not to getting that level of detail, as we get closer to understanding everybody as an individual and being able to treat them individually, this is truly a data and analytics problem. And I think we're living through one of the most interesting times when it comes to that. And the good news is there's been such a renaissance of technology and services and capabilities that we have as people to deliver this, that it really is a renaissance era for us. So my personal belief, what I see every day, is that data is absolutely a compass to the business. And if you don't believe it, you can look at some of the companies up here, which all happen to be customers who are leveraging information and data in very, very unique ways. And when you think about these companies didn't really exist much more than 10 years ago. They were created solely based on data. And in many ways, these companies are data companies that are acting as social media companies, or data companies acting as taxi companies. Not to belittle what any of them do, but at the end of the day, the fabric that they have as a business is built largely around data. One of the greatest challenges that I think a lot of organizations face is that there's a lot of siloed information, and for good reason. Who gets access to data, how they can access that data, when they can access that data, what they can do with that data, importantly has to be protected. But there's a balance going on where we need to be able to actually give people access and let people start to try to correlate some things that might appear to be separate, but could be very much related to the issue at hand. And the gaming example is one of those examples. But so many companies now that we work with, and so many people, I think they're interested in big data, again, not just to stare at the whale, but they understand that to be competitive in their industries, they have to get a grip on information. And they have to think about information the same way they think about cash and other assets on a balance sheet. And they need to look at information as an income statement as well. How much business am I driving? How much costs am I cutting out as a result of the information that I'm using? I talked in the beginning about how logging information is happening all the time now. And another way to look at the data storage costs and size that I described in the beginning is the cost of logging a piece of information. So if you go back to around 1983, the period of that hard drive that I described, it would have been really expensive to take a log file describing something that happened. You barely had enough processing power, storage, memory to do the task at hand, let alone use any leftover capacity to do anything else. One of the things that's not talked about a lot, but we all see it every day, is that because of how cheap it's getting per transaction, everything can be stored. And this is what I refer to as this notion of that ambient cloud. There's an ambient cloud around us where everything we do is creating logs of data. And in the past, if you were a data scientist and you wanted to actually figure out what happened, you would hopefully have a sample size of data looking back at what some small piece of an occurrence was. And then you would stitch together what actually happened. And in many ways, that was sort of the same period as AI that we all remember in the 80s, where it just sort of fizzled out and everybody said, it's never going to happen, that's a joke. Right down the street here at Rivers Casino right now, there are 4 poker players playing against students in their application from Carnegie Mellon University. And last time I checked, the computer's actually kicking some butt. So what's happening? When you think about machine learning in this next phase that we're in, I'll tell you what's happening. There's so much data and processing power now that you don't have to get a sample size of the data. You can look at what actually happened. You can recreate history of almost every single thing that happened. And it won't be long that from a watch like this, I can go back and see exactly what I did. And from other types of sensors, I can see exactly what I ate. But this slide and these economics are exactly what's driving that. It is cheap enough now that we can capture log information. And so another funny thing that's happening with AI is the old version of AI was kind of like, take a task and tell me exactly how to program that task and figure out every permutation of what I need to know to play the game or do whatever it is. Today's version is a lot different. You know what today's version is? And the work being done here on driverless cars is a great example. take a ton of information and figure it out. That's a very different version of artificial intelligence. And I bring it up because I think big data and machine learning, which is one subset of artificial intelligence in that work, they're all very closely tied together. And it gets back to the economics that you see in this slide. And as that happens, more and more devices, more and more information, more and more applications, more and more products and services inherently are going to have analytics built in. And I'll talk about some of the use cases beyond it, but we all hear about Internet of Things, Internet of Everything, and that's almost as big a buzzword now as big data. But there's a reason for that. When you think about the cost per transaction, there's no reason why every single device shouldn't be monitoring every single thing that happens. We have one of our partners that has a hardware device, and it collects a lot of information about what's happening. And their traditional model was that they would have a support center, just like a lot of our own companies, and somebody would have an issue and they would call in. And since they started this predictive maintenance capability in their product, where it phones home, goes into the central data warehouse, gets analyzed, issues get actually noticed and created, now over 90% of the support tickets in the same support system are being generated by this application. And this company is then proactively reaching out and saying, we want to upgrade this or change this because we know it's going to help, before many of the customers actually realize that there's a problem. And so I think, as sensors and IP networks and addresses get embedded into more and more devices, if you think about the back end and the collection point of all this information, that's where you're going to see enormous demand for driving real change. But again, the thing especially after throwing out all these terms around huge volumes of data and all these transactions, the other thing that I see all the time is so many companies just want to do big data just to do big data and get involved in information and analytics just to say we're doing it. And I think we're finally in this period now where a lot of companies have invested in a lot of technology and a lot of people, tried a lot of things, most of the time a boil the ocean approach, and now everybody's trying to look at the ROI and they're saying, well, what did we actually get out of this? What has this done to the business? Because just collecting data for data's sake, no CEO, no CFO, no CIO cares about that. But what did it do for the actual business? And so again, it gets down to the use cases. It gets into the areas where people are taking a specific application or use case and saying, well, what am I using for data? What other data might exist? And how could I change the way we're doing this, which is much about people and processes as it is the technology, and make it better? I talked about the silos. I just talked about the high expectations that everyone has. All this stuff, I think, creates some headwinds for big data. If you just look at the press and the articles over the last 5 years, it's funny. When we first started, I guess, doing big data, it was about 2007 on the Vertica side, and a major telco was our first customer. And they had roughly 3 terabytes of data. And, but we didn't ever call it big data. We just called it analytic database, and we'll take your call detail records, and here's what we can do. But I remember one thing that happened around 2011 is big data started taking off. Everybody talked about it. And we said, there's just too much hype about it, and it doesn't describe what we do well enough. Well, I went and presented to a company that is based in South Korea, and I don't speak Korean, and so we had a translator, and I gave my presentation. And after the presentation, I said, are there any questions? And so the translator asked this team if they had any questions. And it was sort of 5 or 6 words of Korean, and then I heard big data, and then 5 or 6 words of Korean, and then big data. And I realized all of a sudden that this notion, this sort of gravitational force around the term big data, even though a lot of people may not know exactly what it is, I think it's representing this pent-up demand that so many of us have had, frankly, over decades in the IT business, of all the things we want to do, from AI and machine learning and more proactive customer care and predictive maintenance and truly understanding a customer 360-degree view. It represents all that. But from an expectation standpoint, it also creates incredibly high expectations. And so many companies struggle with how to turn these expectations into reality, what to actually do, what to invest in, how to make it happen. For me, I think there's a couple key learning points that I've seen out there. Definitely data access helps to power that innovation. But as I said, it also stresses a lot of people out, because who gets access to that information? But what we're learning is companies that are most successful with big data will take a whole bunch of information, get it into one spot, and let a certain number of people do whatever they want with that information, looking for correlations. And when you start working in that type of environment, and you can have a business unit come and say, here's a whole bunch of information, tell us what you see, and then random insights come out, like the insight I mentioned on the gaming example, great things can happen. It's always better questions that get better answers. And having a dialogue and a conversation with data usually leads to follow-on questions, paths that you can go down. Nobody up front, there was nobody at that gaming company that said, actually, how fast somebody hits the screen and the rate of change is going to be a perfect predictor of churn. They just look for things. And this is where data visualization comes in handy too, because you don't have to be a PhD or data scientist to see some of these correlations. Even though those poker players might be losing right now at the casino down the road, I don't think the technology is going to replace people anytime soon. There's a lot of dirty data out there. There's a lot of interpretation that has to happen and correlate back to the business or the organization, and that will always be very important. But the tools to help empower people to make those decisions are definitely going to enhance it. And then obviously managing the risk goes without saying. So when I talked before about the old way of doing things, which was, grab a sample set of data, do some analytics, some correlations, make sure it's statistically significant. We're in a very different world, the world of log everything. Even if you don't know whether or not you're going to need it, it's cheap enough that you should. Analyze everything. Take all that information, look for correlations that you would never imagine before. The sample size is basically almost infinite. Don't think about, let's just do this with a small subset of our customers or our patients or our clients. Apply it to everyone and everything. And then really importantly, the segmentation equals me. The personalization of delivery, deliver it to me. And I think we've all seen this somewhat annoyingly maybe in the advertising space, where you get retargeted as you go around the web, and the last thing you searched for starts popping up everywhere on your browser. But I would say that the online advertisers in particular have been very good at figuring out these algorithms for personalization. And what's really interesting is that a lot of these same algorithms are now being applied in the healthcare space, in the medical field around personalized medicine. So there's a lot of learnings you can get from things that may seem completely different, but are actually quite related. Having ecosystems, having whatever the systems are, whatever the technologies are, this is maybe somewhat of a shameless plug, but it really doesn't have to be our technology. I think the important thing is make sure you have different technologies, the right tool for the right job, and make sure they can all tie together so that you can get what you need out of that information. One of my favorite customers and use cases that I've seen, and some of you may have seen it, but when it really dawned on me the power of what a lot of information is, Facebook has this great image which basically is a map of the world, and it's a black background, and then you can see white dots and curves between the dots. And what it represents, and they track it, they look at it to see where their base is, but every dot represents a person in the world, and every arc represents a friendship. And they started basically with just a black plasma canvas with nothing. And then when they ran those geo data points of where people were, it literally drew a map of the world. And you can see, some obvious areas that are a little bit darker, like China, parts of Africa, where for whatever reason, internet access just isn't there. But when you visualize something like that, it really, you step away from those trees, and you basically get to see the forest of how it's all coming together, which is really fun. I've already mentioned some of the medicine work, some of the work around sepsis. I think personalized medicine is huge. Uber, what can you say about it other than it's completely changed the way transportation works in so many different ways. But again, it's really a data company. And they also are doing a lot of work, particularly in areas that are less served by traditional taxi companies. How do you deliver that capability in areas where you wouldn't ordinarily have that type of coverage? And then Internet of Things around industrials and machines and how you manage that equipment with companies like Trane. I've just seen so many examples where you can take that information and make really, really profound change. And I think what every great organization that we work with is doing around data is taking, again, not so much reaching for the entire universe, but saying we're going to take a piece of information, or we're going to take a particular business unit, and we're going to understand the data. We're going to look at a lot of different data sets, and we're going to see if we can drive anything. And then what they also do is they have that feedback loop where they're continually saying, what happened? What did we learn? And how can we actually make this better? And as we start seeing more and more machine learning happening, and you get that data into these systems, that feedback loop is going to cycle through faster and faster and faster. And again, to use that example of what's going on here between CMU and the poker players, every night after they finish playing, I think at 8 p.m., the system actually gets a bunch of new feedback fed into it about the game that was played, what actually happened, and they put it on their supercomputers, they crunch it, and it's ready to play again the next morning. And I think you're going to see in every industry that cycle is going to speed up more and more, and the size and velocity of the data will just continue to increase. But like I said in the beginning, I think we are living in a super exciting time when it comes to information. It is doing so many great things for companies, society, people. And I think we're all going to look back and realize that we were in the middle of this sort of mobility and big data, and frankly, even things like cloud computing that were fundamental to enabling that change. And that economic trend line that you saw, I think, is just going to get cheaper and cheaper to collect these logs and do things with it. And ultimately, it's going to result in some great things. So thank you for taking the time to listen to me this morning, for having me here. I apologize again about Sunday, but it is great to be in this city. And I've been coming here for a lot of years as we've had our team here. And it's also really great just to see the city of Pittsburgh change so much from a technology perspective. And now, not just when I'm here, but I read so many articles about all the innovation that's happening at Duquesne and Pitt and CMU and so many universities that you have here. And I think when you combine that with the industry that you have here, the people that you have here, it's just, Three Rivers is a great place for it all to come together. So thanks a lot for having me. And yeah, I'm happy to take some questions. We have a couple more minutes here. If there's a question that anybody has, happy to take it.
Any questions or comments? Reactions? Really? All right. Well, how about a round of applause?
Yeah, thank you very much.